Have you met Defiant yet? Stick around, I'll show you how to set it up right now. We are now at the Defiant console. Thanks to its built-in integration with Gateway 2.0, you can link your Phantom family sensor directly to it. Let's take a look at Defiant's features and find out what sets it apart from being just a data receiver and transmitter. In the wire sensor tab, we can see our 4 digital channels and 16 analog channels. Let's see how to configure the activation of an output based on the signal provided by a sensor. The analog channel inputs have 3 pins. The first pin is for discrete signal, such as voltage or current value. The second pin is designed for accelerometer readings. The last pin in the row is a common node, also known as ground. Make sure to follow this pin layout when connecting the sensor to avoid any errors or malfunctionings during data reading. For the digital output, the first pin serves as the input or output, and the second one is a common. Let's connect, for example, a single-axis accelerometer to the 8th analog channel. We access the channel configuration by selecting the icon. By default, the channel will be disabled. Now we need to specify what type of sensor or input we are receiving on this channel. For our sensor, we'll select accelerometer. Let's configure the sensitivity and dynamic range for this specific accelerometer model. Some accelerometers require a 20-volt power supply to function properly. We can enable that supply by selecting this checkbox. If your Defiant is linked to an AI Analytics account, in the next step you can assign this channel to a specific point in your machine tree. We apply and save the configuration by selecting Set. Since we've enabled the 20-volt output, a warning message will appear to inform us this action. It is important to be aware of the 20-volt activation to avoid damaging other sensors that may later be connected to this channel. A yellow label above the respective channel will indicate that the 20-volt supply is active. Now let's configure 3 different outputs. We'll connect an Andon-style power light to the digital outputs. Let's go to the console. By default, any of the channels will be set as input. Select Output to display the configuration options. In the first checkbox, we can choose whether the output should be normally active, staying at 12 volts and switching to 0 volts when the condition is triggered, or normally inactive, staying at 0 volts and switching to 12 volts when the condition is met. Let's add the condition that needs to be met for this channel to be activated. By selecting Add Condition, we can add as many conditions as we want. For each condition, we must specify which input channel we are referring to. We'll also need to indicate which variable we are measuring. For this accelerometer, we can choose between acceleration, velocity, or displacement. In this case, we'll select RMS velocity. For this example, we'll define 3 ranges: less than 5 mm per second, between 5 and 8 mm per second, and greater than 8 mm per second. Now, let's define how long the condition must remain true before the channel is activated. We'll set it to 0 seconds for immediate activation. Next, we choose whether the output should activate only when all conditions are met, or if it should activate when any condition is met. Finally, we define how long we want the output to remain active. We can set it to stay active as long as the condition remains true, or reset for a fixed time after the condition is triggered. And last, we define the delay time, how long the Defiant should wait after activation before it can trigger the output again, in case the conditions are still met. That's it! We saved the configuration and now Defiant is monitoring in real time for any event or abnormality. Can you imagine everything you can do now that you know Defiant? If you'd like to learn more about real-time monitoring, condition monitoring, and related products, please visit www.𝐼𝐴Z-instruments.com.